In chemistry, it's always important to use the correct quantities or measured amounts of reactants. For example, when making pancakes, you want to ensure that you consider the most efficient and economic use of the ingredients or resources. I mean, what happens when you have excess pure Canadian maple syrup? You can't just drink it, or can you? From the balance equation for a chemical reaction, it's possible to calculate the exact quantities of reactants consumed in products formed. For example, consider the reaction between hydrogen gas and oxygen gas to form water. From the balance equation, it's evident that for every mole of oxygen gas that reacts, 2 moles of hydrogen gas are needed and 2 moles of water will be produced. This is referred to as the stoichiometric ratio. But consider a situation where the ratio of the numbers of moles of reactants available is not the same as the ratio of coefficients in the balanced chemical equation. In this situation, one of the reactants will be limiting and the other will be in excess. Let's look at this more closely. In the first example, the ratio of number of molecules of hydrogen to the number of moles of oxygen is 2 to 1, the same as the ratio of the coefficients in the balanced equation. In the second example, there are more oxygen molecules than needed to react with all the hydrogen. The oxygen is present in excess and some remains unreacted after the reaction. Hydrogen is the limiting reagent, as the amount of hydrogen present limits how much water is formed. What about the third example? Can you guess which reactant is in excess or limiting? Here's a few seconds to think about it. Mathematically, it's easier to work with moles as opposed to molecules. The quantities would just be too large. So, here's an example. Hydrogen gas can be produced by the reaction of zinc with hydrochloric acid. If hydrochloric acid containing 2.74 grams of HCl is added to 3.27 grams of zinc, let's try and work out which is the limiting reagent, how much hydrogen gas is produced, and how much excess reagent remains unreacted. So first thing is first. Let's work out the balanced chemical equation to work out the stoichiometric ratio. Now we can't work in masses, so we must convert both reactants into moles. So here's a shortcut. Now because the ratio is 1 mole of zinc to 2 moles of hydrochloric acid, it's pretty obvious that we definitely do not have enough hydrochloric acid to react with the 0.05 moles of zinc. Therefore, hydrochloric acid is our limiting reagent. So now we know the exact number of moles that's going to be reacted. We can now work out the number of moles of hydrogen gas being produced because it's in a 2 to 1 ratio, and then we can convert this moles into mass, so here we go. Lastly, we need to work out the amount of zinc that's left unreacted, so yep, and yep. Then we calculate the number of moles of zinc that remain unreacted, which is our initial amount of moles minus the amount of zinc that is reacted, which is this, yep. And then we convert it to mass, so moles equals the mass of molar mass, so mass of zinc equals this, there you go.